Hello guys, in this video we are going to talk about the Go language and concurrency in Go.
Now let's look at some basics of Go and Go routines. Here we have a table of keywords. Many of the things are pretty common, like for and if. We have chan for channel. We have Go for Go routine, which we will talk about later, is something relevant to concurrency features. But we still have uncommon things like deferred. But this video is mainly focused on concurrency, so if you're interested, you can find material and learn it. Here we have our first program in Go, Hello World. We have three keywords here. We have package to declare that this program is in the main package. We import fnt for the plain line function. We have funds to declare that this is a main function. In Go, there are several ways to declare a variables. To declare a variable, we need the keyword var at the beginning, and then the name of the variable, and then the data type. You can assign a value to the variable if you like, but not necessarily. Besides, we can declare like this and this. But one point I want to mention is that there are a special way to declare a variable called short variable declaration. In this case, this variable has no type. Here is an example showing us that if we don't assign value to a variable, the compiler of Go will give them a default value. In this case, we can see that the default value for data type int is 0, the float is 0 as well. In terms of bool, it's false, and anti-string for string. Here we have an example for loop. Again, this is short variable declaration. I think the syntax of for loop in Go is quite similar to C. We sum up from 0 to 9 and print out the sum. It's 45. Now let's look at the concurrency in Go. First, I will talk about Go routines, and my partner will continue to talk about channels and mutex. A Go routine is a lightweight thread managed by Go runtime. We can start a new Go routine by the keyword Go like this, followed by a function. In the first example, we have a say function here, which will print out the input string 5 times for every 100 milliseconds. In the main function, we call the say twice with world and hello respectively, and then we print end. As we can see here, we have 5 words at the beginning, followed by 5 hellos, and then ends. In the second example here, we simply add a Go here before we call the first say. In this case, a new Go routine will be created, and the say word will be executed at that new Go routine. As we can see in the output, the words and hellos are printed side by side, which means that the both Go routines are executed simultaneously. In the third example, we move the Go from the first say to the second one. In this case, the hellos disappeared. Why is that the case? Once the Go routine has been created here, the third line will be executed immediately and the program terminates. So there is almost no time for the Go routine we created to print out anything.
Hey everyone, I will now be covering channels in Go. So as previously shown, Go routines allow you to run code, or more specifically functions, concurrently by moving them onto a different thread. However, the other big part of concurrency is communication between these threads. Go allows communication via the built-in primitive channels. Go encourages using channels, and this idea is really emphasized in the slogan. Do not communicate by sharing memory. Instead, share memory by communicating. Communicating sequential processes, or CSPs, using channels is the bread and butter of Go concurrency. Channels in Go is like the channels we have looked at in Promella. Channels have a zero value of nil, but we cannot pass or read data from a nil channel. The make function is used to create a usable channel. Channels are declared with the chan keyword, and the data type of the channel, which can be any Go data structure, such as ints or strings, must follow. A value corresponding to the channel type can be sent to the channel by declaring a channel, followed by the arrow, and the value you want to send. To read a value from a channel, you have an arrow pointing away from the channel, and this value can be stored in a variable or directly passed into functions for processing. By default, sending a value on a channel blocks the goroutine until the value is read, and similarly, trying to receive a value from an empty channel also blocks. This synchronizes goroutines without having to explicitly define locks or conditional variables. When passing channels as function parameters, a direction can be specified. This indicates that the channel will only be sent to or received from in a function. This helps increase the type safety of your programs. A select statement can have several channel operations in case statements, and goroutines is blocked until one of the operations can be run. A random case is chosen if multiple cases are ready. This is similar to the Prometheus if statements. A channel can be closed by calling close on it. Closing a channel indicates that no more values will be sent to the channel. Let's now have a look at some examples. Here in this program, we have a worker function, which takes in a channel that has a direction. The arrow pointing towards chan means that this channel will be send only. Then it will print start working, sleep for 1 second, send 1 to the channel, sleep for half a second, send 2 to the channel, and sleep for 1.5 seconds and send 3 to the channel, and finally it closes the channel. These timeouts could really be API calls or any sort of asynchronous functions. If you're working on a game, for example, these can be used to fetch the user's data or item data or whatever you need to fetch. Here in the main function, again, we create a channel and call the go worker, and we wait on a loop to receive input from channel. When a message is sent onto the channel, message here will contain the message content, and more here will indicate whether the channel is closed or not. If the channel is closed and all values have been read from the channel, then more will become false. Let's see this program in action. So we see if print starting work, then after a second, it says work is finished. After half a second, it says work finished 2. And after 1.5 seconds, after that, work finished 3 is printed, and then all work is done. This is a very convenient method for your application to fetch data from APIs or servers or wherever you can get your resource from. Communication between goroutines via channels can also be asynchronous. When creating a channel with make, a second parameter can be specified to determine the buffer size of the channel. This allows the channel to buffer up to size number of messages before blocking any goroutine trying to send to the channel. Trying to receive when the buffer is empty will still block. Let's see an example. Here we create a channel with a buffer size of 1. We then push the value first onto the channel, then receive from the channel and print it, and we push second onto the channel, receive from that, then print it. Let's have a look at it in action. As we can see, first is printed, then second, just as we would expect. However, if I was to move the second send up here and rerun the program, we get a deadlock. Since the buffer fills up after receiving first, it blocks when we're trying to push send onto the channel. Because no other process will be able to unblock this main goroutine, we end up with a deadlock. Let's now talk about the goods and bads of Go channels. Firstly, they are convenient, easy to get working. You don't need to mess with lower level constructs, which can easily pollute your code base. The default blocking behavior helps prevent race conditions and other problems which arises from sharing data. However, if you're not careful, goroutines can deadlock very easily, as shown in the example of the buffer channels. Also, larger Go data structures like maps and slices are mutable, so passing the pointers through channels may create race conditions. A goroutine not synchronized by specific channels could be modifying structure at the same time as one which is in sync. Go also provides a mutex through their standard sync library. It grants mutual exclusion through its lock and unlock method, and it can be used just like a binary semaphore. And that is all we have time for in this video. Thank you all for watching. Hope you've learned something from it. See you.